Hello students, welcome back. The topic for today's discussion is chromosomal aberrations. We will study two types of chromosomal aberration. One is numerical, the other is structural. Here in this video we are going to study or we are going to emphasize on structural changes of chromosome, that is structural chromosomal aberrations. Right? See, this change or alteration can occur anytime. Okay, alteration of individual chromosome may occur spontaneously or by induction. It can happen on its own, that is spontaneously, or it can be induced. Right? Now see, look here nicely. Changes, it can be broadly classified into two categories. First is what? Changes involving the number of genes. First is the changes that involve the number of genes. Okay. Next category is what? Changes involving the arrangement of genes. So here it is concerned with the count, that is number. Here it is emphasizing on the arrangement. See, this changes involving the number of genes can again be categorized into two subheads: deficiency and duplication. You can understand deficiency has got something to do with reduction, duplication has got something to do with addition. Deficiency again can be of two types: terminal deletion and interstitial deletion. Terminal deletion will occur at the termini or at the ends, and interstitial will be in between, that is intercalary, in between the genes and not at the ends. Here you see duplication. This can be categorized into four types: tandem, reverse tandem, displaced and transposed. We'll talk about each of them later. Next, see, we are coming to changes involving the arrangement of genes. This again is broadly divided into two categories: inversion and translocation. Inversion can be paracentric and pericentric. One is involving the centromere, the other is not involving the centromere. Translocation can be simple and reciprocal. Right? So this is about the classification of structural changes of chromosome. Okay? Now we will briefly describe each of these terms. So let's start with terminal deletion. What is this? It is the loss of a segment of chromosome, okay, that includes telomere. Terminal means what? The segment is lost from the end. Right? Interstitial deletion is what now? A segment between telomere and centromere is lost. Here it is including telomere only because it is terminal. Here it is interstitial. Okay? This a segment between telomere and centromere is lost. Then coming to tandem duplication. Remember we had talked about two types of deletion here, that is deficiency and deletion, they are same. Terminal we have talked, interstitial we have covered. Next coming to duplication. Duplication, how many types we have talked about just now? Tandem, reverse tandem, displaced and transposed. So let's talk about tandem. Tandem duplication is what? A chromosome segment present in more than two copies in the same nucleus. one particular segment is present in more than 2 copies. That means more than 2 copies of that segment is present in the same nucleus. Here the additional chromosome segment is located just after the normal segment, but note gene sequence being the same. So here what is it saying? The additional chromosome segment is located just after the normal segment. The normal segment is here, suppose, and the additional one is located just after this, but the gene sequence remains the same, right? Next we are going to talk about reverse tandem. What is here? Gene sequence of the additional sequence is reversed, that is inverted. In the previous one, what did we say? The sequence remains the same. There is no alteration in the sequence. But here you see the gene sequence of the additional sequence is reversed. Right? Next, coming to displaced duplication. Displaced duplication is what? The additional segment located in the same chromosome but away from normal segment. Displaced means what? It is away, it has got displaced. Okay, the additional segment is located in the same chromosome. It's not that it is located somewhere else. It is located in the same chromosome but away from the normal segment, right? Next, coming to transposed duplication. What is that? Additional segment here is located in a non-homologous chromosome, right? It is located in a non-homologous chromosome. Okay. Next, coming to inversion. What did we say? There are two types: paracentric inversion, pericentric inversion, right? Okay. Paracentric and pericentric. These two. First, we'll start with paracentric inversion. A chromosome segment contains genes in a sequence which is reverse of normal. Here, the inverted segment does not contain centromere. This is the most important line. It does not contain centromere. Please note this. Does not contain centromere. Very, very important line. So, what did it say? A chromosome segment contains gene in a sequence which is reverse of normal, right? Inversion, reverse of normal, but it does not involve the centromere. Okay. Let's see what's there in pericentric. The inverted segment, it is same. The inverted segment contains centromere. One is without centromere, that is paracentric. The other is pericentric, which involves the centromere. Next, coming to translocation, simple translocation and reciprocal translocation. What is this? The chromosome segment integrated into non-homologous chromosome. Here, a segment of chromosome integrated into a non-homologous chromosome. That means what? The chromosome segment is integrated into a non-homologous chromosome. That is simple translocation. What happens? See, the chromosome segment is getting integrated to non-homologous chromosome. Mind it, non-homologous chromosome. And here in reciprocal, the segment of chromosome is integrated into non-homologous chromosome from which a segment is integrated into the first one. Okay, note this, integrated into the first one, right?